Yesterday we have studied normal form. We have started with normal form, and we have seen that there are two kind of normal form. The first one was the Chomsky normal form for CFG, and the next one is the Grebach normal form. Right? These two normal forms were nothing but simply a context-free grammar with some restricted rules. Right? That is, the rules were restricted to have a particular format. And we have also seen that CNF, by converting a context-free grammar to CNF, it was easy to decide whether a particular string can be generated by a given grammar or not. Whereas if a context-free grammar is converted to Gray-based normal form, then it was easy to prove the equivalence between a context-free grammar and push-down automata. Right? That is, generation of push-down automata is easy with the help of Gray-based normal form. That is right. And again, Gray-based normal form can also be used for parsing. This we have already seen in the previous class. We have also seen how we can convert a given context-free grammar to a Chomsky normal form, that is CN. In today's class, we are going to see how we can convert a given context-free grammar in Gray-based normal form, so that we would be able to obtain a push-down automata which is equivalent to the given context-free grammar, right? So there are certain steps that need to be followed in Gray-based for converting a CFG to Gray-based normal form, and we'll see these steps one by one, and then we'll go through all these steps by considering an example of converting CFG to GNF, right? So the first step is to eliminate all null productions and unit production from the grammar. Right? We have already seen in the previous class that any grammar that does not have epsilon, or the language, there is no epsilon in the language, then such context-free grammar can be represented either in CNF or GNF, right? So if there are no null production, no unit production, then we can obviously convert it to GNF or CNF, right? So if a given grammar is there and there are unit production or null production in the grammar, then we have to eliminate them, right? And we have seen the process of identifying unit productions or null productions and eliminating them. So the first step is to eliminate null production and unit production, and the next step in the first step itself is to convert the given grammar to CNF. We have already seen how we can convert context-free grammar to CNF in the previous class. So this is the first step, that is, we'll convert the given grammar to CNF. And obviously, for converting to CNF, we don't need any null production or unit production in the grammar. Then the next step is that in the given grammar, we would be replacing all, or renaming. Instead of replacing, we can say that we would be renaming all the non-terminals, right? Suppose there are n number of non-terminals represented as NTN. Then we would be replacing or renaming them as A1, A2, and dot 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 AN, so as to provide a sequence to the non-terminals, right? And A1 will be our start symbol, right? So we would be renaming all the non-terminals so as to provide a sequence to this non-terminal by as A1, A2, or you can say X1, X2, or S1, S2, any kind of non-terminal you can name them, but it should provide a sequence. So we'll give a sequence to it, right? So the second step is to rename all the non-terminals. I'm talking only about non-terminals, not about terminals. So we would be renaming all the non-terminals in a way that we would be providing sequence to these non-terminals as A1, A2, dot 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 AN, wherein the first label, that is A1, will be the start symbol. Then the next step is here we would be learning two lemmas, that is two properties that are to be applied to this production rule so as to convert them to GNF, right? So first in step 3, we would be applying lemma 1, right? So what is lemma 1, we'll see, but when it is to be applied, like suppose there are production, then we have renamed these non-terminals, so you will get the production rule in terms of A1, A2, and so on, right? So in this case, you will look at the production rules, and if you identify some production rules wherein the left hand side variable subscript, that is the non-terminal which is on the left hand side of the production, then if its subscript is less than the right hand side variable subscript, right? if it is less than the right hand side variable, that is the leftmost symbol on the right hand side and the left hand side symbol. If the subscript of the left hand side symbol is less than or equal to the subscript of the leftmost symbol on the right hand side, if it is there, then well and good, will not do anything, right? But if it is the case that is the left hand side subscript, that is the like suppose there is a rule in ai derives to aj and followed by a non-terminal from nt, right? So if this is a rule and the value of I is less than value of j, less than or equal to value of j, then well and good, we don't need to do anything. But in case some rules are there wherein the subscript value of left hand side variable, that is I, is greater than j, then that is a problem. So this is to be eliminated, and for that we would be making use of lemma 1. What is lemma 1? We'll see in a while, right? So you need to just look at the subscript value. If the subscript value of the left hand side variable is greater than the subscript value of the leftmost symbol of the RHS of the production, then we have to apply lemma 1, right? So this is step 3. And in step 4, we need to make use of lemma 1 and lemma 2 again, right? Along with lemma 1, we need to apply lemma 2 also. And then by using these two lemma, we'll be converting the given production rules into GNF format. We'll see what are lemma 1 and lemma 2. So lemma 1 says, uh, suppose there is a grammar G equals to VTPS, then in this, if the production are of this particular type, that is A derives to A alpha. Now here you can see that this symbol which is on the left hand side of the production and the symbol on the right hand side of the production, the leftmost symbol on the right hand side of the production, these two symbols are same, right? Okay. Or you can say that the subscript of this symbol is greater than this symbol. Okay, the left hand side symbol is greater than the leftmost symbol of the right hand side. Then what we would be doing, and there are other rules of A which are in the required format, that is I is less than J. So we'll say that these rules are beta rules. So alpha rules and beta rules. Alpha rules are those rules wherein this condition is not satisfied, that is I is less than equals to j. If this condition is not satisfied, then we say that such rules are called as alpha rules. Whereas if this condition is satisfied, then such rules will be termed as beta rules. So A derives to beta 1, beta 2, dot, dot, dot. There can be n number of beta rules. There can be m number of alpha rules also, right? But we'll consider one in case of lemma 1. If there is a left recursion, A derives to A alpha. This kind of case is there, that is the subscript of the left hand side and the subscript of the right hand side is same, right? So in that case, what we would do, we would replace this A by all its production simply, and we'll make a new production. So G dash will be V, T, P dash and S. So we'll add a new P dash such that this A will be replaced by all the beta rules, that is the right hand side of this beta rules. So it would become A derives to beta 1 alpha, beta 2 alpha, dot, 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 beta and alpha, right? So what would we'll do, we'll simply replace this A with beta. Okay, and then these beta rules will be as it is. Okay, we will be keeping this rule as it is, but in place of this A, we would be replacing it with all these beta rules. Okay, so this is simple lemma 1, wherein if these two symbols are same, we can replace it like this. Okay, then there is lemma 2. Then again lemma 2, G is given VTPS, will convert it to G dash, wherein the production rule will change. Now suppose here I was talking that there is a single rule like this, but there can be multiple rules, like A can derive to A1, A alpha 1, A alpha 2. That is the first symbol will be same, but there can be multiple rules wherein the first symbol is same as the left hand side symbol, but after that there can be any combination of variables, right? So like this, suppose there are production rules such that A derives to A alpha 1, then A alpha 2. Here alpha can be anything, any combination of terminal and non-terminals. Okay. So, but this alpha 1 will be different from alpha 2, alpha 2 will be different from alpha 3 and so on. So there are multiple rules such that the left hand side for this a only, that is this and this is same, but after that there is some different combination of terminal and non. And there are certain beta rules. Again, beta rules will be the rules that are in GNF or that follow this particular structure, that is I less than j, right? So either in GNF or they are following this structure, that is the subscript of left hand side is less than equals to the subscript of the right hand side. So if this condition, this type of production are there, then what we will do, we will introduce a new non-terminal, let us call it as Z. So we'll be adding new non-terminal Z that would be like this is a left recursion, so we would be making it right, we'll removing this left recursion. So for that, what would we do, we'll add a new non-terminal Z and we'll attach it with alpha 1, so that now this is left recursive, will remove this left recursion by adding a rule like this. So we'll add a rule in P dash such that we'll keep the beta rule as it is, that is a derives to beta 1, beta 2, dot 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 beta, and all these rules will be as it is. And now along with this rule, we'll introduce a new non-terminal like this, a derives to beta I z, right? Now this Z will be introducing alpha over here. For that, we would be writing rules for Z. So first of all, what we'll do, we'll write the beta rule as it is. Beta rules are the rules which are in required format. Okay, alpha rules are the rules which are not in the required format. Okay, so we'll write the beta rules as it is, a derives to beta I. Then what we'll do, we'll add a new non-terminal Z for this beta rules. So A derives to beta IZ. So it would be beta 1Z, beta 2Z, beta 3Z, and so on, beta NZ for all the betas rules. Okay, and then we'll add rule for Z such that it would introduce alpha on the right hand side, right, like this. So we'll add a rule for Z, that Z can be replaced by alpha j. Now j can be, it can be alpha 1, alpha 2, dot 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 alpha m. So Z will either derive to alpha, because this a, suppose this a is replaced by beta 1, so you will get beta alpha 1. But now this can be obtained like this, a will derive to beta iz, right? Here also you would be getting the same thing, like suppose I am using a derivation like this. Suppose this a derives to a and alpha is there, right? So it would be deriving to a alpha. So this same thing, by implementing these rules, we are obtaining the same thing, but here you don't know how many times to extend this a, when to end. This is a problem, right? So you don't know this thing. So for avoiding this is called as left recursion. When to stop, we don't know. So for that purpose, we are removing this left recursion, and for that, what we will do, we will introduce a new non-terminal. So for deriving a alpha itself, what we would be doing, we would be using this rule first. That is, it would derive the same strings. Like a will now derive to, it would derive a alpha in two steps. First, it would be writing beta I, suppose beta z, beta 1z, right? Suppose I want to derive beta 1 alpha. So this a can, now I am eliminating this, right? So this a will be replaced by beta 1, suppose. So the string that would be generated is beta 1 alpha, right? So the same string can be generated over here. So I would be using first rule a derives to beta 1z. And then for z, I have already added alpha rules. That would be alpha 1 or alpha 2. Suppose this is alpha 1. So I would be getting a string beta 1 alpha 1. So first I would derive a derives to beta 1 z, and then for this z I have already added alpha rules. So this would be replaced by alpha itself. Okay, so this would be alpha 1. Now suppose you have that this a can be replaced by any beta 2, so you will get beta 2 alpha. Suppose alpha, you get alpha 2, so you can replace it with that alpha 2 rules, right, like this. So you would be deriving the same kind of productions or the strings. Okay, so we would be adding Z to beta rules. We'll keep this beta rules as it is, and for Z we'll add alpha rules. So Z will derive to all the alphas, or will, for adding a recursion to it, for repetitively using it, we'll be introducing a right recursion. So we know when can we stop, because If the string is completely matched, the last z will be eliminated automatically, right? So this z will derive to alpha j z. Okay, so this would be the lemma 2. Suppose there are multiple rules such that the left hand side symbol is same as the leftmost symbol on the right hand side, but the remaining symbols are different, then we would be introducing a new non-terminal z. You can introduce I have used z, you can use x, you can use y, any non-terminals, such that a would derive to all the beta rules, and then for removing the left recursion we would be introducing a new non-terminal z such that it would repeat beta I z, and for z it would replace it with alpha j, or for recursion we would be introducing again z, that is z derives to alpha j z. We'll introduce it as a right recursion, not left recursion, and then the value of j will be greater than equals to 1 but less than equals to, this should be I have kept it n, so this should be m, right? This is m. Okay, it should be greater than equals to uh, j should be less than equals to m and greater than equals to 1. So this is m, not n. Okay, so these are the steps for converting the given cfg to gnf. Do you have any doubt? Anyone having any doubt in this? Well, Uh, so we'll see an example of how to convert a CFG to GNF. So this is a context free grammar which is given to you, and this again there is a mistake of typing error over here. It should be convert the given grammar to GNF. Okay, so this is a GNF. Huh. So we'll convert the given grammar to GNF as this is already in CNF, right? Uh, is this in CNF?
Yes, sir.
Yes. So this is already in CNF, and the first step for converting a given grammar to GNF is to convert it to CNF. Now, the first step is already fulfilled because given grammar itself is in CNF. So we need not do the first step. As there is no null production, there is no unit production, and the grammar is already in CNF. So we'll not follow the first step. We'll directly move to second step. But we need to check, right? We need to verify if the given grammar is not in CNF or it has some unit production, null production, then we need to eliminate them and convert the given grammar to CNF. This is the first step. Then second step is to rename all the new non-terminals, right? All the non-terminals. So here you can see that there are two non-terminals only, S and A. So we need to rename them as A1, A2, right? I have used the terminology A1, A2. You can use X1, X2 or any other terminology. So as we know that the first number should be given to the start symbol. So your S will be A1 and A will be A2. If there is other symbol P, so it would become A3. If there is another symbol Z, it would become A4, right? Like that. So here we would be renaming A1 for S and A2 for A. So these two rules now will become A1 derives to A2, A2 is non, this terminal will be as it is for A, and A2 derives to A1, A1, B. Now we have completed step number 2, right? We have renamed the given non-terminals S by A1 and A by A2, and accordingly these are the new production rules. Is this clear?
Yes, sir.
Okay. Then in step 3, what is step 3? In step 3, we need to check whether these production are in CNF or the left hand side subscript is less than or equal to the right hand side subscript or not. So if you look at here, so this is the left hand side subscript which is 1, and this is the right hand side subscript which is 2. So 1 is less than or equal to 2, condition is satisfied.
Yes, sir. Yes,
Yes.
sir.
In this rule, the condition is satisfied. so we'll not do anything, we'll not apply lemma 1, right? But if you look at this rule A2, so the subscript is 2, and here the right hand side subscript is 1. So 2
1.
is less than equal to 1.
No.
No, the condition fails over here. So we need to apply lemma 1 over here, right? So what we'll do, we'll like in step 3, we know that this rule is in the format because I is less than equals to j. But in the second rule, A2 derives to A1, the I is greater than j. So the condition is not satisfied. So we need to apply lemma 1. Now, what does lemma 1 say? Lemma 1 say that we'll separate the rules as beta rules and alpha rules, right? So here, this is the alpha rule. A2 derives to A1 is alpha rules, and B is a beta rule because this is in the required format. Okay, so what we'll do, we'll apply lemma 1, and this A1 is to be replaced now. So we'll be replacing this A1. This is symbol A1. This is giving problem. So we'll be replacing this A1 with all its rule. So this first A1, the leftmost A1, this will be replaced by its all beta rules. So A1's beta rules are A1 derives to A2. This is in the given format, required format, and A1 derives to A. This is also in the required format. Okay, so what we'll do, we'll replace this A1 with these two productions and rewrite the rules for A2. So A2 derives to A2 because this A1 is now replaced by the first rule of A1. So it would become A2 A1. Then second time this A2 this A1 will be replaced by the second rule of A1, that is A. So it would become A1, and this B will be as it is because it is in the required format itself. This is terminal only. We have not said anything about terminals, right? So according to lemma 1 now, these A2 rules will become like this. A2 derives to A2 A1, A2 derives to A1, and A2 derives to B. Now you can see that this subscript is less than equals to this subscript, and here there are terminals, so there is no issue over here because this is in GNF. GNF says that there should be a single terminal followed by series of non-terminal on the right hand side. So this is accordingly in GNF, or there should be a single terminal. So this is also in GNF. So these two rules are already in GNF. The issue is with this rule only, but here also the condition for step 3 is satisfied, that is A2, and this is also A2. So I is less than equals to j. Okay, so we need to apply lemma 2 over here, right? Because this is 2, but it is not in GNF, right? This is okay, but it is not in GNF. Now for converting it to GNF, we need to apply lemma 1 and lemma 2 simultaneously. So we can apply either lemma 1 or lemma 2. So here you can see that this A2 is equals to A2, and there is a single rule for A2. Okay, so we'll be applying lemma 2 over here. Here, what A2 derives to A1 and A2 derives to B, these two rules will become beta rules, and this will be alpha rules for lemma 2, right? Like this. So here A2 derives to A1 or B. This is equivalent to A derives to beta A. That is, these are the beta rules. And A2 derives to A2 A1. It is equivalent to A derives to A alpha 1. Then there can be A alpha 2, there can be A alpha 3. So this but here there is a single rule, so this is single only alpha 1, right? So it is equivalent to this. For this we know that we need to introduce a new non-terminal along with the beta rules like this. So we'll be adding, what we'll do, we'll introduce a new non-terminal for beta rules, and then we'll add a new production for these z rules. What we'll do, we'll add z to this beta rules. So the rule will become like this: A2 derives to A1 as it is, A2 derives to B as it is. That means beta rules will be as it is. Then we'll introduce a new non-terminal for all these beta rules. So it would become A2 derives to A1Z. This is as it is. Along with this, I have added Z, and A2 derives to BZ. That is, this is as it is beta rules, and along with it, I have added Z. right? So beta rules will be as it is, but along with it, we would be introducing a new non-terminal and adding new production as A2 derives to A1Z and A2 derives to BZ, right? Now, for this, we need alpha, that is, this part should be repeated again. So instead of repeating this part by left recursion, we would be adding a right recursion. So this Z should be able to replace A2, A1, right? So what we do, we add a rule as Z derives to alpha J. So here alpha 1 is A2, A1. So this Z should derive to A2, A1 and it should be repeated. So we'll add another rule as first rule will be Z derives to A2, A1, because if I want a single derivation, so I would directly replace it with alpha. So Z derives to A2, A1 will be there. And then if I want to repeat it multiple times, so I would be adding another rule, that is Z derives to A2, A1 alpha, right? Sorry, Z. Okay, like this. So I have added two rules for Z. Z derives to A2, A1 and Z derives to A2, A1, Z. So now using this, for this single rules, I have introduced 1, 2, 3, 4 new rules, right? By introducing a new non-terminal Z. Okay, so now these rules, A2 rules are in GNF, like this is in GNF, this is in GNF. Here there is a terminal followed by series of non-terminal. So this is also in GNF, terminal followed by non-terminal. This is also in GNF. These two rules are not in GNF. The Z rules are not in GNF. We will see how to convert them. A2 rules are in GNF. A1 rules, these are the A1 rules. So these are also not in GNF. Now we have converted all A2 rules in GNF, but Z rules are not in GNF and A1 rules are also not in GNF. All rules, right? This rule is in GNF, but A1, the first rule, is not in GNF. So we need to convert it. Now for converting it to GNF, we need to again apply lemma 1 and lemma 2. Are you getting what I am trying to explain?
So last step not understood, that Z derives to A2, A1 and Z derives to A2, A1, Z.
Have you understood lemma 2?
Mm.
Lemma
Yes,
2.
that beta one understood, but alpha one not.
See, I have explained you that derivation. Like suppose you want to derive a string alpha 1, uh, sorry, what was the string that I considered? Yes, the string was beta 1 alpha 1. I said that if you want to derive a string beta 1 alpha 1, so if this kind of rules are there, we would be simply using the left recursion. But when to stop this string? That was not possible if there was a left recursion, right? So here we what we do, we like suppose you here, if we consider this particular example, and now suppose you want to, what string I can consider, right? Suppose now here I want to derive a string BBA from this, right? So if I want to derive a string BBA from this A2, so see, when I'll replace this A2, so I can replace this A2 by, I want the string to start with B, so I can replace it with single B, right? So if I replace it single with a single B, that is A2 derives to B is a rule. So then I won't be getting BBA because that is a single terminal and terminal cannot be replaced by any other rules, right? Then there was another option that A2 can be replaced by A1, right? So if I replace it with A1, then again I won't be getting BB at the start, right? So I cannot use this rule also, right? So I was having only one option. I am having only one option, that is I can use the derivation for this particular rules, right? So I would be replacing this A2 with A2, then again A2 and A1, right? So this was the rule that can be used, right? Then again this A2, right? So again this A2 can be replaced by any of these three rules, right? So I can use this rule, I can use this rule, or I can use this rule. So there is a confusion which rule I should use. So accordingly, when you design a parser, there is an option that is first time we'll use first rule. Whenever there is a first time expansion for a particular variable, normally we would be using first rule. So accordingly, every time when a2 will be expanded, it would be expanded by using first rule itself for the first time. So when this a2 will be expanded for the first time, it would be replaced by a2 a1. Second time this a2 will be expanded for the first time, again it would be replaced by a2 a2 and then a1,
A1.
right? And again this a2 will be, because we need to go to the depth of the tree, so every time this would be expanding as a2 a2 a1, every time this will happen, right? Because this will be the first time first rule, right? This will
Yes.
study in detail in when we'll study compiler design in the next semester. So here the compiler or the processor is not able to decide when to stop expansion of a2 by this rule and move to other rules. There is a confusion, right? So this confusion is because this is the leftmost symbol which is equivalent to this symbol, that is this is called as left recursion, because we are going only in the leftmost direction, right? And every
Hmm.
time the same symbol is used. So there is a confusion to the compiler that when to stop, at what level we should stop. So as to avoid this, what we do, we introduce a new variable and we say that instead of left recursion, we'll make it right recursive. So now in that case, what will happen? See, I have made it as bz, right? So if I want to introduce a rule, if I'll go through this sequence, suppose this is deriving a1, so this will not work for me because it would derive to a string starting with a. So I will eliminate this, because for the first time I would be using first rule, but this fails because it does not match to the string, so I will eliminate this. Then second time I would be using second rule. So A2 derives to B. So this will be directly a terminal string which is not equivalent to BBA. So this will also be eliminated. Then I will again do backtracking. This process is called as backtracking when we move to the next step. Then there will be third rule. So according, I would be replacing A2 with A1Z, right? So again here the string is starting with a. So this A will not match with BBA, the string that I want to derive, BBA, right? This string will not be derived again by this, right? So again, I will go and backtrack it. So again, I will go back to A2, right? So as there is a terminal over here, I can match it with this string. But here there was a non-terminal only. I was not able to match it with this string. Then I will see the last rule, because again I'll have to go back because this string was not matching. So lastly, I would be using this rule, A2 derives to BZ. So now what I will do, I will derive A2 and I will use a rule A2 that derives to BZ,
Z.
right? Then this is B and Z. Now this B will be matching with the first symbol of my input. So at this point, I am correct. Up to this point, I am correct because the first symbol of the input is matching with the required given data, right? In this derivation. So I'll move to this new non-terminal. Now this new non-terminal should be able to produce again B, A, right? So I would be using the rule of Z. Now the work of A2 is done, so I would be using the rule of Z. Now Z has two rules. Now suppose I was simply to derive BA, so I would be using the first rule itself. But suppose I again want that it to derive BA, right? Suppose the string is BA. So suppose I use the first rule A2 A1. So what I'll do, I will replace A2 and
A1.
then there will be A1, right? So here for A2, I have this rule again. So as per the requirement, first time first rule will work. So for the first time, this A2 will be replaced by A1. So you will get A1. But if you match it with BA and this BBA, so that will fail. So again, you will suppose this is the case. So you would be for first time first rule you will apply. So it would become A1, right? So when you will match again the terminals, so BA, this will not match with BB, so this will fail. So what you would do? again you will backtrack. Backtrack means you will go back to the previous step and see for, look for another rule of A2. So if you look at the another rule for A2, so you will get the next rule for A2, that is B, because first time first rule, second time second rule. So you will get a B over here, right? So you can replace this with B. So now if you match it, it would become BBA. This is A1, right? So BBA1. So this BB will now match to the first two symbol of your terminal of your given input string. So this is correct now. Then this you will go to this non-terminal now, A1, right? So A1 will again you will check for the rules of A1. Now I would eliminate, suppose this rule is not there. So A1 will directly derive to A. So what I'll do,
A.
for time being, I am eliminating this, right? So suppose A1 has only one rule, so I will directly replace it with A, right? So if this was the string, now I have derived to a string A, B, A, and I want that it should stop. Suppose this is the only string, right, that I want to derive. What I'll do, I'll stop over here just by using the rule A. So I know now I want to stop if this string is BBA because it is matching with BBA. So I would be using a rule this like this. But suppose it is not there, right? So I want that there should be again BA. So then here I need to go back again, do backtracking. So I would go back over here and see that it is not matching to the required input because I want again BA over there. So I would be, there is no other rule for A. So then again I need to backtrack. I will go back over here again, right? And then all the possibilities I've considered for this particular rule, it is also not deriving to BBA. So I will again move back over here, right? Now I'll go
Right.
to the next rule of Z. So the next rule of Z will be A2, A1. Now there will be additional Z over here like this. Okay. So similarly again we'll move ahead for this Z. So this A2 will again introduce B, this A1 will introduce A, and now this Z will again use these two
A2
rules,
and A1.
A2, A1, and then it would, so this will become A2, this will become A1, and then again by the same process this A2 will derive B and this
B
A1 will derive
and
A. So now this
A.
string will be BA, that would match the required input. You understand? So now
Yes.
here I know when to stop because now it is matching with the terminal string. But in the previous case I was not knowing when to stop. So this was a problem. So I need to eliminate this problem. For eliminating this problem, I need to introduce, but the string should not change. The string that are generated by the language should not change. That's why I have to introduce such rules. Do you
Okay.
understand?
Understood. Yes, sir.
Okay. Hope it is clear to you all.
Yes.
If not, we'll discuss it again when you'll, this will be clear when we'll study parsing in compiler design. This would be more clear over there because at that time you would be aware about what is backtracking and what is parsing. That would be clear over there itself. As I said that GNF is also used for parsing, it is helpful for parsing. So this way it would be helpful for parsing. Like this parsing is nothing but it is used for checking the syntax. Like suppose in C language you are writing something and the syntax is not correct. So how this compiler knows that the syntax is not correct? So for that there are certain CFGs which are written, and this CFG, if a particular part, like suppose you are writing a if statement, so for if statement there is a CFG and it would derive a string. So suppose uh, the string that you write, suppose if bracket open A is less than equals to B, then curly brace open and then some syntax is some statements are there and then curly brace close. If this input can be derived by a CFG, we have seen derivation. Suppose this can be derived by a CFG which is written in C compiler, then the syntax of if statement is correct. So the derivation will take place in the way that I have told you in the few minutes back, like for deriving BBA and BBABA. in that way. And if the parse tree is generated, the tree structure for this input is generated, then we say that it is syntactically correct. And if not, then it is syntactically incorrect and the compiler gives you error. And the error is identified, like suppose in the derivation time, suppose there was ba and there was no string that is deriving to ba at the end, so it would generate an error that this point there is a generated but you have not written a, or you have written a but it is not generated by the parse tree. So that at that point there is some error. Accordingly your compilers are designed, right? So well, let it be. We'll see in the next semester. So here we have applied lemma 2 and then we have converted it, we have removed left recursion and introduced right recursion by introducing a new non-terminal z, right? Then if you look over here, then a2 rules are in GNF as I told you, and this a1 rule is not in GNF and z rules are not in GNF. So first we'll replace this a1 rules. So for step 3, this is clear, I is less than equals to j, so that is okay. But then we need to apply lemma 2 or lemma 1 so as to convert it to GNF. So for GNF this should be replaced by a terminal, and we know that all the A2 rules are in GNF. So what we'll do, we'll simply replace the first A2 by all the GNF rules of A2, right? So what we'll do, we'll simply replace the first A2 in the right hand side by all these rules and keep this A2 as it is, right? So first rule of A2 is A1 AA1, so we'll replace this A2 by AA1 A2. Then second is B, so we'll replace this A2 by B, so it would become BA2, right? And then third rule is this A2 will be replaced by this rule, so it would become A1Z, and this A2 will be as it is. Then lastly, this is BZ, so this A2 will be replaced by BZ, and this A2 will be as it is, so it would become BZA2. Now you can see that this is following the structure or the syntax of your GNF, that is a terminal followed by series of non-terminal, terminal followed by series of non-terminal, terminal followed by series of non-terminal, terminal followed by series of non-terminal. So all these rules are now in GNF. Is this okay?
Yes, sir.
Yes. एक ही लड़की पढ़ रही है लगता है क्लास में. Then Z rules. Now you can see that these are not in GNF. So Z productions are not in GNF. So we need to again convert them to GNF. So we'll see at this first symbol. Again, this A2, all the productions are in GNF. So we can replace it with the productions of A2. And this is also A2. So we can again replace it with the productions of A2 and then write the rules again. Similarly, like in the same fashion as we did for A1, so we'll do it for Z. So instead of this one rule, that is Z derives to A2 A1, we'll introduce 1, 2, 3, 4 new rules, right? Like this. So it would become Z derives to A1 A1, then B A1, then A1 Z A1, then B Z A1, like this. Okay. And then for this also we would be replacing the first A2 by all its beta rules. Beta rules are nothing but the rules which are in the required format. Okay, so it would become like this. So this A1Z will be as it is, and the first A2 will be replaced by all these rules one by one. Okay, and then this A1 is already in GNF and A2 is already in GNF. So we add these two, this we have seen. So now all these rules are in GNF. Is that clear? So we have converted the given grammar to GNF.